In this video, we're going to talk about electron arrangements and orbital diagrams. So we looked at electron configurations in the previous video very briefly, so we'll go into those in a little bit more detail. This is also considered the subshell occupancy, because really all you're looking at is how many electrons are in a subshell. And then we'll also think about orbital diagrams, which is specifically looking at how many electrons are in each orbital. So you get a little bit more detail. So just as an example, an electron configuration would be the 1s2, 2s2, 2p3, for example. An orbital diagram is where we think, okay, I have a 1s orbital, it can hold 2 electrons, and their spin is opposite. The 2s orbital also holds 2 electrons. And then the 2p, there's 3 p orbitals, and I'm going to put 1 electron in each first. So that is what my orbital diagram would look like. So notice the difference. You get more detail. You can think about paired versus unpaired electrons. So we have paired electrons in the 1s, we have paired in the 2s, and in this specific example, we end up with 3 unpaired electrons in that 2p subshell. So you might have seen pictures like this, especially this one on the right. It's very commonly used for thinking about how to write electron configurations. And it's fine, but you have to either remember what this picture looks like or memorize the pattern or whatever it might be. Same thing with the diagram on the left, right? It's helpful to see how we have shell overlap, all right? We're not going to go just in numerical order. Sometimes the 3 comes before the 4. But again, you're memorizing. So the next slide, we're going to talk about a better way to be able to look at a periodic table and actually figure these out. So here's an example of the periodic table that lays out how the orbitals correspond to the periodic table. So we have what we call the S block. So that's going to be groups 1, 2, plus helium that's over here by itself. We've got the P block. So that's groups 3 through 8. We've got the D block, so that's all your B groups, your transition metals. And then the F block are this extra 2 rows that are always popped out, the lanthanines and the actinides. So what you're going to do to use this is you're going to find your element on the periodic table, whatever it might be. Let's just pick this one right here, whatever it is. I don't even care what it is right now, okay? So to write the electron configuration, you're going to start at the beginning, and each box counts as an electron, and we're going to fill those in until we get to the element that we care about. So the first row is 1s. There's 1s here and a second 1s, so that's 2 electrons. It's full. Then the next row is 2s. We've got 2 there. Then we have 2p, and there's 1, 2, 3, 4, 5, 6. Next row down is 3s, and there's 2 of them. Then we come to 3p, and 1, 2, 3 is where we stop. So there's your electron configuration. So again, you can do this without the P, S, D labels, right? It's pretty easy to see how this corresponds to the shape of the periodic table. The one thing that you do want to try to keep in mind is by the time you get down to the 4th row here, you have 4s, but then the transition metals actually start with 3d. So this is where that orbital overlap comes in. So if I had an element that was over here in the 4p spot, I would have I'd have everything up to 4s2. So then I have 4s2, 3d10, and then I go back to 4 and I stop 2 spots in, so 4p2. So you want to keep that D block in mind, that the numbers drop. Same thing with F block. See, F block fits in right here. So you're going actually from 6s to 5d to 4f, or depending on the order, really it should be 6s, 4f, 5d, which is what this is showing here. So let's try a couple examples here. First one, we have sulfur. And if you look at a periodic table that actually has the elements in it, you will see that sulfur is located right here in the periodic table. So our first row is full, so that's 1s, and there's 2 spots. Second row I have 2s, and there's 2 spots. Next spot is 2p, and I have 6. 3s, and there's 2, and then 3p, and I'm going to stop at the 4th block over, so this is going to be 3p 4. So there's your electron configuration for sulfur. If we look at barium, barium is located right here in the periodic table. So let's work our way down to barium. So first is 1s, and there's 2, 2s, 2, 2p6, 3s2, 3p6, 4s2, 3d, and there's 10, 4p6, 5s2, 4d10, 5p6, and then we'll get to 6s2, and we'll stop. So there's your electron configuration for barium. A shorthand way of writing this is you can find the noble gas that is in the previous row, and in this case that is xenon. So I could write this with xenon in brackets, so that means everything with the electron configuration up to xenon. So that stops with the 5p6, and what I have left is 6s2. So this right here would be another way you can write the electron configuration for barium.